Okay? We introduced it last week when we were talking about geometric sequences, where you had an exponent. Okay? So that was your introduction, like, hey, we're starting exponents. Here we go. Now we're going to talk about the actual exponential function itself. Okay? So the exponential function is a function, obviously, in the name, in the form of f of x, aka y equals a times b to the power of x. Okay? Where a can never equal 0. A will never be 0. Okay? And b can never be 1. That's what this equal sign with the slash to it means. It cannot equal that. Period. End of story. Done. Okay? So A can't be 0, B can't be 1. Now, what is A actually? A is your y-intercept, or starting value. If you're given an ordered pair, it's when x is 0, the y value is whatever A is. B is either your growth or decay, aka growth meaning I'm getting taller, or decay, I'm getting shorter or smaller. All right? Now, there's a reason why B can't be 1 is because I have to have something showing growth or getting smaller. Okay? If I have 1, it's just even. Okay? Now, growth is any number greater than 1. Any number greater than 1. That's what a growth would be. Decay, this right here, is any number between 0 and 1, aka a fraction or a decimal. Fraction or a decimal. Now, do you notice that it's not a negative number? Okay? It's not negative. The B value cannot be negative. Okay. Here's the special term that is, I believe, is completely new to you. It's called a horizontal asymptote. I know there's a P in there, but it's a silent P. Asymptote. Asymptote. Okay? Now, the horizontal asymptote is just a horizontal line, a boundary line, okay? A floor is what best way to put it. It's like a floor that your graph approaches but will never cross. The horizontal asymptote is basically just a floor that, or a wall, could be a wall, okay? A floor, sorry, not a wall, a ceiling. It's like a floor or a ceiling that my graph will not cross. That's all it is, okay? We'll get more practice with it here in these examples, okay? So right now, everyone needs to get their calculator and turn it on. Now, we're graphing exponential functions, okay? The easiest thing to do is to get the table first. Now, if I give you the equation, my strategy for you is to go to your calculator, okay? And everyone's going to hit this button right here, y equals. So everyone hit y equals, okay? And remember, f of x is y. Okay, so there's my y right there. I'm just going to type that equation into my y equals 4. Okay, now how do I get into the exponent on a calculator? That, not up arrow. What do we call it? Caret. Call it a caret. Okay, hit the caret, and I'm going to put the letter x. So remember, next to the alpha button is the x, tau, theta, nu. That gives you your x. Greek alphabet. You're just now telling me you need a pencil? Then you raise your hand. Does anyone have a pencil for Ace to borrow? Thank you. Now, I want to complete the table first. Okay? Does anyone know how to get to the table on the calculator? How? Nope. Second, the blue button. Okay? Then hit the graph button. Do you see how the word table is in blue? Do you see how the word table is in blue? So if I want the blue part, table, I'm going to hit the blue button. Second, graph, to get a table. Now, my graph here starts at what? X equals what? So I'm going to scroll up to -2. What is the X value? 0.0625. When X is -1, what is Y? What is my y-intercept? Nope. 1. Remember, the y-intercept is when x equals 0, the y value is the y-intercept. Okay, so let's make a little note. This right here is my y-intercept. Finish the table. When x is 1, y is 4. When x is 2, y is 16. Uh-oh. Oh, you're at stat.
Okay.
Wait, what?
No.
Oh, you don't have anything in your...
I do. Put it on forever.
I see that.
Thank you.
Okay, Jackson. What did we say was our y-intercept? 1. Okay, y-intercept 0, 1. Good job, everybody. Good job. Okay. Now the horizontal asymptote. The horizontal asymptote is if I add or subtract any value there. Now, was there any plus or minus in my equation? No. I had no adding or subtracting in the equation. So my horizontal asymptote is y equals 0. Why am I putting y and not x equals 0? I'll give you a hint. Horizontal, and a horizontal line has what type of equation? Y-intercept, or y equals. Okay, not the y-intercept, but y equals. So my horizontal asymptote is at y equals 0. Which means that is my floor or ceiling. Okay, depends on the equation itself. That is my floor or ceiling. Okay, let's go ahead and graph this here. So I'm going to go to x is -2, and then I have 0.065. Now I don't know exactly where that is, but I have a rough idea that it's somewhere very close to 0. -1, 0.25. Again, I don't know exactly where it is, but I know it's somewhere between 1 and 0. 0, 1, 0, 1. The y-intercept, aka where I cross the y-axis at. Then I have 1, 4, so x is 1, y is 4. When x is 2, y is 16, which would be way up there. Now this is not going to be a discrete graph, it's going to be continuous. So what do I need to do to the dots? connect them. So I'm going to have this line go all the way this way, but never crosses the horizontal asymptote, never crosses it. So I just kind of get closer and closer and closer to it without crossing it. And then the other direction, I'm going to go whoop. Now, what did I draw on the end of each of those directions? Arrows. So it's continuous. It means we're dealing with infinities. Okay? Now, if I'm dealing with infinities, domain. Domain. How far left do I go? Negative infinity. How far right do I go? Positive infinity. I told you that there was a special symbol in today's warm-up. What is that special symbol? All real numbers. All real numbers. Can I give you all a secret? Your domain will always be all real numbers with exponential functions. Okay? Period. Your range is what's different. Okay? Range is low to high, right? Now, low. Do I go downward infinity? No. Because of what is stopping me? The zero, the horizontal asymptote. Okay? That's stopping me. Now, will my line ever equal 0? No. My line will never equal 0. However, will it always be above 0? So my y value will always be above 0 for this equation. Now, because we are moving, if I look at my graph, I'm moving in the upward direction, it's growth. Because I'm moving in the upward direction. Yay! No! Why no? What's happening? Oh. The Velcro came off? No, I was being funny. We're in the J's. Example number 2. All right, example number 2. First and foremost, what do I want you to do? Pull out your calculator and click on y equals. I'm going to clear out y1 so I can do a new equation. All right, that equation is alpha x to get my fraction bar, 1 half, get out of the fraction, up caret x.
I'm assuming it's a negative graph.
Alpha x to get my fraction bar, Jackson. Alpha x to get my fraction bar. Then I do 1 over 2. Then I'm going to hit right arrow to get out of the fraction. Then I'm going to do caret x. Okay? Now, from here, we want to get to the table. How do I get to the table? Second graph. And here's my table. At -2, what was my y value? You have 4. At -1, what was my y value? 2. At 0, what's my y value? 1. Now, when x is 0, that y value is my what? Y-intercept. So I'm going to make a note of that. Okay? 1. Half. We can do 0.5 or the fraction. It's up to you. Okay? 2. 1/4 or 0.25. Either one works for this situation. Because we're going to graph it. Now, we already know the y-intercept. It is 0, 1. Perfect. Now, remember the horizontal asymptote is anything added or subtracted to our equation. Is anything added or subtracted to our equation? No, so our horizontal asymptote is y equals 0. Okay? So I will not cross the x-axis. Now, domain, I can answer this without even graphing anything. Domain will always be what? All real numbers. Because we are infinity, negative infinity to infinity. Because of the arrows. Alright? Now, to do range and growth and decay, I do need to graph. Alright? So I'm going to go to negative 2, comma 4. Negative 1, 2. 0, 1. Then a half. And then 0.25. Okay? Now I'm going to connect these to the best of my ability. That is ugly. Okay, there's my graph. It's not perfect, but it's there. Okay? Now remember, to figure out growth and decay, I want to look at it like I'm reading a book from left to right. So as I go from left to right, is my graph going upwards or downwards? Down. So that would be decay. Basically. The range. Am I above or below my horizontal asymptote? I'm above it. So my y value will be greater than my horizontal asymptote. Range is y is greater than or less than the horizontal asymptote. Okay? A little tidbit. Because we're about to do another graph where we have a different horizontal asymptote. Okay? So turn the page. We're going to skip number 3 because it's just like number 2. All right? Except the fraction is 3/2. Okay? What? Maybe. Maybe. So here's what I want to do first. I want to graph that. Y equals. Okay, now please pay attention. Ooh, get out of there. So I have negative 2. You hit this button right here. Just hit y equals. Okay, I have negative 2 parentheses. Fraction 3/2, close the parentheses, then I carry it up to the x. Just like it's written here is exactly how I type it in. All right. Go to our table, second graph, and here's our table. So, when x is negative 2, what do I have? Or 0.88. Okay, negative 0.88. All right, when x is negative 1, y is? Which is negative 1.3 repeating. 0 is negative 2. That is my y-intercept. Good. Okay, I'm just going to make a note of that over here. 0, comma, negative 2. 1 is negative 3. 2 is, which is negative 4.5. Okay, and then I'm going to do an extra one just because. Not just because Jackson was like, are these the only points we're doing? No. So I'm going to make an extra point. When x is 3, what is y? Negative 27 over 4. Now, if you did that and got the decimal, you would get negative 6.75. So we've already answered the y-intercept. The horizontal asymptote. Was anything added or subtracted to the equation? No. So my horizontal asymptote is y equals 0. So that's my limit. 0 is my limit. Okay? Domain will always be what? All real numbers. Okay? Now, in order to do the range, I need to graph it. So the first one is negative 2, negative 0.88. So negative 2, negative 0.88, which would be kind of around here. Negative 1, negative 0.33. 0, negative 2. 1, negative 3. 2, negative 4.5. And 3, just for good measure, 5, 6. Now let me ask you something before you ask any question, Daniel. Is my graph above or below the horizontal asymptote? It's below it now, right? Okay. So my y is now less than, and what was the horizontal asymptote? 0. See how the range changes? It's all dependent on how you graph it. Yes, sir.
The horizontal asymptote on 0.
No, it is not always 0. Yep.
Can we use the graph thing, like what it gives you the graph?
Yeah, but we got to do the
Yeah,
points
the point, but this point.
to look at it and all that. Yeah, no, 100%. All right, Daniel's asking, like, what if we don't have this? But I give you the table and it didn't ask you all that info. It's easy. You just go to graph. You don't hit second. And then if you watch the graph, it just magic. Mine's really slow. Y'all's moves faster than mine. But boom, there it is. See your graph? You can answer all your questions right there. All right, but moving on. Growth or decay?
Okay.
It's going down.
It's going down.
Decay is when the number is between what two values? 0 and 1. And that's my b value. The b value is what's connected to the exponent. If I look at the b value, the one that's connected to the exponent, 3 over 2 in decimal form is what? Positive 1.5. Is that between 1 and 0? No. Is it greater than 1? Yes. So when you have a graph that goes below your horizontal asymptote, you need to double check your b value and make sure whether or not you have growth or decay. Okay? The reason why I have growth is because 3 over 2, my b equals 3 over 2, which is 1.5, positive 1.5. Right, Sam? Good morning. I can't wait to answer all the questions on your homework because you're like, Coach, I don't know what we're doing. Very consistent process that we have here. All right. Are you ready for the one that y'all keep asking about without y'all realizing that y'all keep asking about it? I'll show you why we keep asking about it. All right, let's go ahead and look at this equation. And before I even do anything, what do I have here at the end of it? I have a horizontal asymptote because something is being what? Added or subtracted to the equation, correct? because I have something added or subtracted to the equation, this right here is my horizontal asymptote. So my horizontal asymptote is y equals -4. Woo! Liam kept asking, is it always going to be 0? No, it's not. Because I finally have something added or subtracted to the equation. Okay? Which means I'm going to go down to y is -4, and I'm going to draw a new barrier.
Does the domain always go left? Oh, never mind.
Domain is always left to right. Now, even though my horizontal asymptote is different, guess what will never change? The domain. The domain is still all real numbers, even though the horizontal asymptote has changed. Okay? Now, to figure out my y-intercept and the range and the growth or decay, the growth and decay, I can look at my b value. My b value, is that number between 0 and 1, or is it greater than 1? It's between 0 and 1. And if I have a number that's between 0 and 1, what do I have? Decay. Okay, my b value equaled 2/3. That is 0.6 repeating, which is between 0 and 1. Okay, so I have a decay. All right, now let's figure out y-intercept and range. Very simple stuff, gentlemen and ladies. I can't speak today. I'm going to type my equation in. 3 parentheses 2/3 x minus 4. Dyer, did I type it in correctly?
No.
I'm waiting for you to come up with an answer yourself without Liam just whispering you nonsense. Did I type it in correctly, yes or no? Huh? No, I typed it in incorrectly?
Oh my god. Yes, you did it correctly.
Did I take this equation and just copy it over?
Yeah.
So did I type it in correctly? I did, Liam. Okay. I need the table. I don't need the graph right now. I need the table. When x is -2, my y value was what? Huh? 11/4, which is 2.75 in decimal form. All right. When x was -1, y was 1/2. When x is 0, y is -1. Hell! When x is 0, y is -1. What is that? Y-intercept. 0, -1. So that's answered. Okay. Then I have -2, -2.6 repeating. Just because Jackson complained. Did 2. Did 2. Did 2, did 2, did 2. We're going to go past -2 or past +2. So 3, 4, and 5 gives me -3.11, -3.4, -3.6. I don't want to hear it. So here we go. I'm going to graph it. -2, 2.75, half, -1, -2, -2.6, -3.1. Closer, closer, closer. I have my graph. Now that I've graphed it, am I above or below my horizontal asymptote? Above. To show that y is above the horizontal asymptote. What is the horizontal asymptote? -4. She was Mr. Barker's sub.
Okay, so she's the new Mr. Barker.
Literally just for today.
No, it doesn't. Mr. Barker's son.
Sub.
Wait, she
Questions, comments, or concerns? Could I have forgot not if I didn't have to graph, I could just do graph and it will graph for me. Eventually, my calculator is slow. Y'all's kind of graphs faster. And as you can see, boom, there it is. Now, what do I not have here?
Points.
Horizontal asymptote. Did you know that I can actually graph the horizontal asymptote? Okay. Horizontal asymptote is what?
-4.
Y equals -4, right? Aren't these all just Y equals eyes? Okay. So in the Y2 value, I'm going to put -4. And then I'm going to hit graph. And look. It draws my y-intercept, or my horizontal asymptote. So you can actually graph your horizontal asymptote to see if I'm above it or below it. Fun stuff, right? All right, let's move on to the next thing. Technically, the last page of notes. Really hope y'all are paying attention and not just Googling things right now. Corbin. Hey, just to let y'all know, from here on out, all computers are closed until notes are done. Period. Done. No, I don't. You know the answer to that. I never do. Yep. Writing exponential equations from a table. Let's finish these notes. So you have time on your homework. Close the computer. Ace,
Yes.
close the computer. Close it. Thank you. All right. Here's our equation. Y equals A times B to the power of X. Okay. A is the y-intercept. Okay. B is the pattern of multiplication, aka the ratio, which is what we did in geometric sequences. What?
So can we just do stat?
No. So, write an equation of the table below. All right. Do I have a 0 in this table? I do, right here. So, what is my y-intercept? 27. That is your A value. Okay. Now, to go from 3 to 9, what ratio is that? Ratio. Not common difference, ratio. 3 over 1. Which means I multiplied by 3, correct? This right here is your B. So my equation is y equals the A value, 27, times the B value ratio to the power of X. I labeled, I substituted. Now you will, on the STAR test, be asked what the equation is and whether or not it's growth or decay. What variable, A or B, tells you growth or decay? B. What was the B value? 3. Is that greater than or less than 1? Greater than. And if my B value is greater than 1, I have a growth. Oh, dire. I will have a growth if my B value is greater than 1. Now, there are going to be times that I don't have a 0 in my table. But I can get to it. Okay? I can go backwards. But to go backwards, I need to know what I do to go forwards. What is the ratio between 625 and 3,125? That's easy. Take the second term, divide it by the first term. Second term divided by the first term. What do I get? So I'm multiplying by 5 to go down the table. If I want to go back up the table, what am I going to do? Divide by 5 to go back up the table. So what's 625 divided by 5? 125. Thank you, Renata. Not Liam. Okay? So, y-intercept is what value? Can someone let Santiago in? What variable is 125? A. The y-intercept. A. It's right here. Guys, it's literally right here. It's literally right here, Dyer. See it? Do you see it, Dyer? It's literally right there. It's the A. Okay? So I have y equals 125 times, what is the original ratio? 5 to the power of x. This is my B. That tells me growth or decay. Which one do I get? I have growth. Because the B value is what? Greater than 1. All right, we're only going to do one last example. Do I have a y-intercept in this table?
Yes.
Yes, what is it?
1.
Okay, so 1. So far I have y equals 1. Now I need to find the common ratio, okay, to go from 5 to 1. So that is your term divided by the term that you're at divided by the previous term. So 1 divided by 5 is your ratio. What does that simplify to? 0.2, or you can just leave it as 1/5.
Is it 0.2?
Yes, Ace. Yes, it is. Would it help you if I did this?
Here, I can do it right here real quick. It is, Coach.
Corbin! Do I have a growth or a decay? Why? What is less than 1? What's the fraction? 1/5. What variable is it? Liam. So why you should know by now to never listen to Liam. What variable? There's only 2 variables, dude. There's literally only 2 variables. Which one is it? It's the B. Okay, it's the B. All right, can I ask y'all something? Okay, I know this is decay. I have an equation of y equals 1 times 1/5 x. Do I need this 1 here? No. Could I leave my equation like this?
Yes.
Yes. Could I also write it like this? Yes.
It's decay, Coach.
Are both correct?
Oh,
Yes, they are both correct. Okay?